As another example, we want to write a recursive method that is called digit match that accepts two non-negative integers as parameters and returns the number of digits that match between them. When we say non-negative, it means greater than or equal to 0. So it is possible that both of them are zeros. And if both of them are zeros, then we assume that this method should return 1 because it has only one digit which is equal to 0, and both numbers have this digit, so it should return 1. Now two digits match if they are equal and have the same position relative to the end of the number. I mean starting with the ones digit. Here is an example. If this is the first number and this is the second number, and here is the ones digit, which is number 1. So we start comparing these digits in the beginning. The method should compare the last digits of each number, the second to last digits of each number, the third to last digits of each number, and so forth. That means we compare 1 with 1, and we compare 9 with 4, and we compare 8 with 8, and we compare 3 with 0, and so on. And in every comparison, we count how many pairs match. In this example, we have exactly 4 matching pairs. The first of these matching pairs are in the ones digit. As you see, 1 is equal to 1, 8 is equal to 8, 5 is equal to 5, and 2 is equal to 2. So how to count the number of matching pairs of the two numbers starting from the ones digits? We are going to follow the same computations that we have followed in the previous example by using modulus 10 to read the rightmost digit and divide by 10 to remove the rightmost digit. After taking modulus 10 for both numbers, then we have the rightmost digits for both of them. We compare these two digits. If they match, then we are going to call the method recursively on the two numbers, but after dividing by 10 to remove these two digits plus 1. So why we add 1 to the return value of this call? Because we have a matching digits. However, if the two digits do not match, then we are going to call this method recursively again on these two numbers after removing the rightmost digits, but this time we don't add 1 to the return value. Why? Because we don't have a matching digits. We keep doing that until there are no more remaining digits for matching. After describing briefly the steps required for designing the recursive method for digit match, now is the time to talk about its implementation. Assume that the two numbers are labeled num1 and num2, and these two numbers are passed as input parameters to the method. Initially, we have the following method definition. It returns an integer that represents the number of matching pairs, and num1 and num2 are passed as input parameters. We have already described how the method calls itself recursively on the two numbers, but what we need to know now is what are the stopping conditions or the base cases. Remember that we are removing the rightmost digits from both numbers in each recursive call, and hence eventually one of the two numbers that has the smaller number of digits will have no more digits to match with the other number. So can we consider if num1 is equal to 0 or num2 is equal to 0 as the stopping condition or the base case? And what will be the return value? If the method returns 0 if one of the two numbers is equal to 0, then how the method will handle the case when both numbers are equal to 0? So the method is going to return 0, however it's supposed to return 1. Why? Because if both numbers are equal to 0, then the number of matching zeros is equal to 1. And if the method returns true if one of the two numbers is equal to 0, then if the two numbers have the same number of digits, and after removing the rightmost digit repeatedly, then both numbers will be equal to 0. And the method in this case is going to return 1. However, it's supposed to return 0 because the number of matching digits will be extra by 1. So in conclusion, the condition if num1 is equal to 0 or num2 is equal to 0 is not an appropriate stopping condition or base case for the algorithm. Therefore, we have to think about another stopping condition or base case to stop the recursive call of this method. So what is the appropriate stopping condition that we need to consider? Since we are removing the rightmost digit for every recursive call, then we are not going to stop the recursive call when one of the two numbers is equal to 0. We are going to stop, however, when one of the two numbers has a single digit remaining. And if this digit is a match with its corresponding digit in the other number, then the method returns 1, otherwise it returns 0. And this condition, as we will see later, will cover all cases that we have discussed previously. So now if num1 or num2 has a single digit, I mean if one of them is less than 10, then we compare the corresponding digits. If there is a match, then the method returns 1, otherwise it returns 0. And this represents the base case that we have just discussed a minute ago. And now to implement it, we write an if statement by testing if num1 is less than 10 or num2 is less than 10. Then we need to match this remaining digit with its corresponding digit in the other number. If there is a match, then the method returns 1, otherwise it returns 0. So for this example, as you see that the first number has more digits than the second number. So after removing the rightmost digits in every call, then the first number will be equal to 107 and the second number will be equal to 6, which is a single digit. So when the method compares the rightmost digits for these two numbers, it will find that there is no match because 7 is not equal to 6 and therefore it is going to return 0. Now for the recursive call, then we need to compare the two rightmost digits for both numbers. If they are equal, then we are going to call the method recursively after removing the rightmost digits for both numbers plus 1 because we have a match. Otherwise, we call the method recursively after removing the rightmost digits for both numbers, but this time we don't add 1 because we don't have a match. And this can be expressed naturally in Java by saying if num1 modulus 10 equals num2 modulus 10, so there is a match, then we return by calling the method recursively, passing the first parameter, the first number after removing the rightmost digit, and the second parameter will be the second number after removing the rightmost digit plus 1 because we have a match. Otherwise, we are going to have the same call, but we don't add 1 because we don't have a match. And this completes the analysis, the design, and the implementation for the digit match method for finding the number of matching digits in both numbers.